Hello, pinball aficionados. My name is Patty Cornish, and this is my dad, the world-famous Gottlieb designer Wayne Neyens. And we are here today to do the sequel to the famous 2011 Wayne Neyens interview. So without further ado, here is my dad, Wayne. Take it away.
Well, I don't know what to say, but we have a wonderful game here. We have a Kewpie Doll made in 1960. 950 games made, and the numbers seems a little low, but it was a good game, and we should have built more games. This Kewpie Doll, because it is a very good game, and Will is lucky to have this game. I say it's one of our better games, and we had a lot of fun setting it up and getting it working. It had a few minor problems. And we got them all licked, and it's a wonderful game, and it's going to be great. That's so interesting to me because I've been looking for this for so long, and so many people told me that you didn't draw 3 circuits. There were only 2, and I said, no, there's a third one someplace. But I drawing these circuits was not my job. I did design work, but when I would get ahead of the production, I would do other things. I'd go out and work around the shop. Sometimes I'd shoot trouble in the bull ring and do various things that would help the company out and keep me busy, because I always wanted to keep busy. But I used to draw circuits occasionally, and I drew 3 circuits, so I always remember them. The way to tell who drew the circuit, there's on the bottom of the circuit, there's always 3 initials and a date and a number. Now the 3 initials stand for the guy, whoever drew the circuit. And this particular one is W-E-N, Wayne Elmer Neyens. Elmer is not well known in the industry, but that's all right. And the date was 9/8/60, and it was game 172. And so when you ever have a circuit, you look at it and you'll see different initials at the bottom. Most of them will be won't be mine, because I only did 3 of them. I had too much business, too many other things to do. But so I was across the factory, and I had nothing to do with the engineering department during all this design work. I worked alone. I had a room by myself, had a drawing board, drill press, a large drill press with a large base that would take a playboard. So it would take the base of the drill press was about, I'd say 3 feet, maybe a little 3.5 feet, and about 2 foot wide. And so I'd get blank boards, and I would start out and lay the board down into a cabinet and sit there and look at it and say, well, what am I going to do now? And then I start working on it, and finally I take parts and lay it on the board, posts and bumpers and flippers and so forth, and then I'd get an idea of what I wanted to do. Then I would finalize it. I'd draw it with a T-square and angles, triangles, and get everything symmetrical. And I never built anything asymmetrical. Krinsky, when he started designing, he did a lot of asymmetrical designs, and he had a lot of drop targets at an angle and that type of thing. No, I never did. Mine was always, every game I designed was symmetrical. As you can see on this game here, that both sides are the same, and that's seemed to be my style. And everyone has a style. Questioned me about why all this open space up in here. And you know, games had to be made to have action. It had to be made to be fun, but it couldn't play too long. If it played too long, obviously the operator didn't make any money, and if it played too short, the player didn't have any fun. So it was always a compromise between what you did on the playboard and what you could get away with and what you couldn't get away with. And in this particular game, I have a lot of space in here, but I needed the space to close up between these bumpers to get the action between the bumpers. There's a certain distance, about 4 inches across here where I like to place the bumpers, about 4 inches across. And here, because they would pop back and forth, but here they don't pop back and forth, so you could come a little closer. And that's why this had, I couldn't pull this back up against the frame here, so you wouldn't have the action. This action right in here is very good on this game. This particular game, the ball dropped through, and it's a way of getting the balls off the table. And when I first made Niagara, we had an awful argument within our own little group in the factory that whether the player would play the game with what they now call gobble holes. And the upper echelon, who had something to say about it, didn't think a player would play a game that lost the ball up the table, and I thought they would if you gave them something. Now we turn it off. Now we start working. All right.
Tell us about that feature of beating on the game to turn it off.
Well, there's a way to shut the game off. There used to be a toggle switch on the game, on the bottom of the game, so the storekeeper could turn the game off, and at night or during the daytime, if you didn't want the noise going on, you turn the games off. But of course, as soon as you have a switch on the outside that can be controlled by somebody, they control it, and they turn it on and off and goof around with the kids. Would turn it off and nobody be playing it. So we came out with an idea of putting a switch on the bottom of the cabinet so that you could hit it with your hand and turn the game off. And of course, the players and the kids never knew that. They couldn't find that out, so it was pretty much of a secret, I guess. This game is wired so that this button will start the game. Now, normally that should not happen. You should put a coin in. Now, if you want a free play unit is shown here, and that would have say that had a 1 on it. Then you could take and push this button and start the game. 25 cents 3 games, 10 cent 1 play. So that would start the game up. But on this particular game, being a home model, and you don't want to have to put coins in the game. The game thinks it's got free plays on it because the switch has been closed back there. So if I press this switch, it's just like as if I had a game on it. Games, Elvin Gottlieb one time said it's worth the price of admission just to watch the game reset. And so you'll see it in here. And those are rabbits and ducks, and there's rabbits and ducks over here. The rabbits are on the red, and the ducks are on the green over here, or the white. And the idea is to knock them down, and every time you knock them all down, then we advance the yellow hats here 1 spot. I'm going to knock them down 1 at a time. 1, 2, 3, 4. Now as I knock them down, you'll notice the rabbits are going down up there. They go off here and off up there. Now nothing happens yet until I knock this side down. I'll do the same on this side. 5, 4, 3, 2. Now as soon as I hit 1, it's going to reset and start up this combination of hats here. And the object of the game is to get to the top here and get it lit and go in the hole and get a free play. So when I hit 1 here, it'll reset them, and so now we have to knock them down again, and we're back here. We got 100. Another feature of the game is as you shoot the ball, it moves these hats along, and as you come through this rollover, it'll give you the one that's lit, red and white on both. This one rollover now will knock down this hat and this one at the same time. And that is kind of an interesting feature. And if you can shoot the ball up here, get the pop opener, knock it up here, come across here, knocks down 2, comes back down, knocks down another 2. And that's the object of the game, is to get these hats, these ducks and rabbits down 4 times. And this time we're going to go up to 4. Now, if you put a ball in this hole here, which is sometimes called a gobble hole, which is a term that I don't use, but everybody seems to like that term, gobble hole. So I've tried to get used to it. You drop the ball in the hole, you get 300 and the special if it's lit, and it's lit. If it's out, I put it out. Now you won't get one now. But if I put one in, as soon as the hole is lit, like that, you see this hole is lit, this one is out, that one's lit, it's on a relay that flips back and forth. Now it'll add a free play. You hear the knocker go? That indicates a free play with one. Now on a location, that would mean that a player could play the game without putting a coin in the game. Now down the side here is this roll over here, very important to the game. This, when you go through here, it knocks down all 5 of the white ones. All 5 of the ducks will go down. Now, if there's only 3 lit, but so the 2 of them will not have any effect on it, but it still scores the same and it knocks down the other 3. We'll knock them down fast. Boy, this would be fun to do. When you got the glass off, this is fun. You can get these rollovers anytime you want. So knock them down in a hurry. See, we advance across here. Now we're lit again. Now I can drop. Now I've still got 5 balls left here. I'm still playing the first ball. Of course, this is very rare. It could ever happen that way. But every time I drop a ball in this hole when it's lit, it'll be 1 free game. Okay, this is a single-player Lightbox. Now, all Lightbox single players are almost identical. As a matter of fact, when I was designing, a lot of times I'd use an old Lightbox that I put together and use it on the next game because it's all identical. You got your free play unit here, you got your score units here, your 0 to 9 units here, and your relays associated with them here. That's all there is in the Lightbox. And every game has the same thing. Occasionally, there might be a 0 to 9 unit might be put someplace else for some reason, but most of the time you'll find it right here, or it could be moved up and down a little bit, depending upon where the artist draws the openings for the score units. Now, we normally give the artist the location where we want the score units, and sometimes we'll leave them down here, sometimes here. Once in a while we'll move them up on top, but we like the name across the top, and so we make this as more or less a normal single-player Lightbox. If you look from game to game, you're going to see this here. These are going to be here, and then this is going to be here, there. But it's all the same, and almost the same circuitry. So when you're putting the game together, when I would do it, I would reuse it so many times until I got tired of using it and had it punched full of holes and things. So. But it is a very simple mechanism. This being the free play stepper here, and as it goes up and closes the switch, it hits the knocker, which is located on the front of the side panel, up near the front door there. So so the player hears it good. And now these relays here, this is the 1-point relay, which would be this unit over here, as you pull it. And this would be the 10s unit. I'll get my hand out of the way. That's the 10s unit. And this is the 100s unit over here. If you learn one Lightbox circuit, and these testers in the factory, when the games change from one game to the next, they already know how it works. And they can just fall right into it. This unit is what we call a 0 to 9 unit. It controls the match. Depending upon where this unit is ends up at the end of the game, it depends upon what the match is. Sometimes it'll be on 9 or 8, 7, whatever it happens to be. This is the unit that determines it. Now these adjustments here, this is the match feature. Now if this, where it's at, shows you you're going to have a match. One controls the light and one controls the 24-volt circuit. You pull that out and put it up here on the top. Now, there's no match in the game. The light will not come on, and no match will ever occur. And the operator has that choice. The match is really a good feature, and most people use it because it gives a poor player a chance to, on occasion, win a game, and that's very important. Now, this adjustment here determines where the high score payout's going to be. And it shows up here that if you plug into this particular socket here, and according to this chart here now, it shows 1100. That means that 1100 would be a free play. Now, it skips 1200, and it goes up and pays one on 13. The next one's 13, the next one is 14, and then 15. So that's the maximum number of free plays you can make on high score on this game. Now, if you didn't want to pay out free plays, you just pull the pins out and it wouldn't score any free plays on high score. That's what this adjustment's for, and you know now what this one's for. We got the relays covered, the free play, the step switches, the 0 to 9 unit. Now these units are held in by what we call hairpins. It's a pin that's, I suppose it's shaped like a hairpin. It was called a hairpin anyway. And they're held in by that, so you take one off the bottom and one out of the top, and when you do that, then the unit is free to come out. And I've taken these two out, and now I can take the unit out from this holder, and I got it in my hand. And now you can see what's inside of it, and you can work it by hand. Put your finger in there, and you can work it. Not a dangerous thing to do at all, and it's a good thing to do it periodically to check your game out. Check the switches out, make sure they're working properly, and one of the switches is a lock-in switch, which makes sure it takes its full stroke. One switch is runs it back to 0. And you got to get back to 0, and the unit's got to know when you get to 0. Now we'll go back to 0. When we get to 0, these switches will drop. I don't know whether you can see them or not, but see them drop down? Now that completed the circuit across here and opened up the circuit on a runoff. So when the game is over, you run the unit back to 0, and when it gets to this point, that switch right here opens up, and that stops this coil from operating. And it will not operate on a reset again until it's off 0. And this switch in here is a lock-in switch to make sure it takes its full strength, its full stroke. The relay. This happens to be the 10-point unit, and this is a 10-point relay. Now I'll operate the 10-point relay here. You see the unit advance. Now if I hit one of these, hit this one, this other unit would advance. The 100s unit. This one won't advance because I didn't hit the 10s relay. There's a 1s relay, a 10s relay, and a 100s relay, and they operate these units. Well, we did the Lightbox, and we know that they're pretty standard. Every Lightbox is very much alike. All single-player Lightbox are really alike, and once you learn one, you learn them all. But now we're down to the bottom panel, and they're a little different on every game. But there's a lot of similarities too. Now, one of the similarities, I'll run through the similarities first, and then we'll pick up the differences in this game versus any other game that you may have. They all have a fuse panel on this side of the cabinet, and there's usually a tilt bob. Now, on this one here, we don't have a tilt bob because it's been left out. Now, every game has a motor. That's this one here. Every game has a transformer. That's this one. And every game has a holding relay. That's this one. Now when that comes on, that holds the circuit game. When that's off, the game is dead. There's nothing on, no lights are lit, nothing, no bumpers will work, nothing. Until you pull this in. And now the game is lit. Now starting in the front here, we have a meter that measures the number of games that have been played. That counts every game, and so you know when you look at this counter how many games were played on your game. So you can have an idea of what it is. Now, next to it here we have the holding relay, like I described before. That holds the game on. And this switch here drops it out. If you bang the game too hard, and that bounces, cuts the circuit off, everything is dead. If you pick the game up, bounce it on the floor, this switch will operate and kill the game. Now, if your game don't work at all, it'd be a good place to look at this switch to make sure that it's got make on it, and that it's got good make on it, because that weight on there tends to open it, and you gotta keep that closed tight. Now this transformer, transformers are dangerous. You got to be careful. There's 115, 20 volts on there, and you don't want to get your hands on it. Even when the holding relay is off, and the game apparently is dead, 110 volts is still on that transformer. It's not hot, but you can get your hands on it and hurry and get hurt. So be careful around that transformer. Now back in the back, you can see plugs that lead up to the Lightbox and to the playboard, and we'll talk about that a little later. And then we got an extra shoot relay over here, and every game has an extra shoot relay in it. So there's so many similarities. That relay works with the quarter shoot. When the quarter shoot is when you drop a quarter in the chute, the quarter shoot relay operates and runs up 3 free plays or 5, whatever the adjustment is set at. Right, and now this next one spots the 5 ducks down. I haven't seen the one that spots the 5 rabbits. I've kind of been looking for that one, but I haven't seen it yet. But this one knocks it all down, all 5, and you close the switch up here with the rollover switch as an example. You pull this relay in, the motor, now, if you come back to the motor here, it's a very interesting motor, and you will see on our diagrams a diagram of the motor showing the different positions. We have 1A, 2A, 1A, 1 and 2, 3, and 4. Now, this is the 1 stack here. 1A would be on the bottom. So if you see a switch marked 1A on your diagram, you don't look any place but right. Take the motor, find where the coil is in the motor, come diagonally across, and makes this stack 1. Well, if you're on 1A, if you're looking for a switch on 1A, there's only one place to look, and that is on the bottom of this stack. The bottom switch is 1A. I noticed on this particular motor, there's no way to raise it up. Now, on later games, there's a cotter pin that holds this motor into place, and you can pull that cotter pin out, and the motor raises up so that you can work on these switches from the side. And this one you can't do it. You'd have to almost raise the bottom panel up, which would mean take you 2 screws out, one here and one here, and then you could take the bottom panel and raise it up, pull it out and raise it up wherever you want to, and be able to work at this thing. This motor was very difficult to work on, I can see. Okay, we're on the playboard, and we're going to discuss this this relay bank here. Now, this relay bank is the 5 rabbits and the 5 ducks, and you'll notice that there's 12. It's a 12 relay bank. There's 10 coils representing the 5 ducks and 5 rabbits, and 1 common between the 5 ducks and the 5 rabbits. Each one has a common relay. Now, when the 5 ducks go down, and we'll trip them down, 4, 5, that's 4. Now the 5th one. Now what happens is the 5th, the one relay in the middle goes down because there's a bar across that underneath there, welded to the armature, would have been an armature, to fall down and operate the switches. Now when I knock the rest of them down here, we're going to knock the rest down. I'll come to the last one. When I knock the last one down, it is just like the first 5. It will close, it will go down, and it's the center one here, which don't have a coil, will close because it has a bar across and knows now that there's no relays up. So I close this, the motor's going to run, and it's going to reset. And that is the sequence, that's what this bank does. Now there may be other games with something similar, but this game is unique in that respect that there's 5 rabbits and 5 ducks and they operate in, you have to have them all down in order to get an advance. Different games you have to do different things, and on this particular game there's 2 out holes, or called gobble holes, up the board, and it's right opposite my fingers here, and we had to build a trough to direct the ball from that point back down to the starting. So these troughs are made like this. It's a little bit tricky design, but it went together pretty good. But what it did, it caused us to have trouble here. As you can see on this flipper link here, this flipper link here is so much longer than this one. You notice this was only maybe 3 inches long, or this one's about 5-6 inches long. And that was because we couldn't get this coil any closer. There's lights under here and switches and stuff, so we couldn't. These switches had to be guarded and protected, and we couldn't get in there. Artwork was all done by a gentleman by the name of Leroy Parker. Every hat dimensioned, every hole dimensioned, every rollover dimensioned. And when the artist got it, he had to lay that out on his board, probably laid it on his table, and maybe put a sheet of vellum over the top and drew over the top of it. But then when it came down to the final artwork, he had to be very accurate. He had to be right on the nose with that stuff. And so then he would take the original sketch we gave him of the location, and he would draw. And now, as an example of Kewpie Doll, he would draw, and he would probably put Kewpie Doll across here as a start. He may start right there. Say, well, that's a good thing. We'll put it right up there, and of course all these red dots, the red lines, that always is. And put this on here. That has to be at the top. You wouldn't put a shooting gallery down at the bottom. So, using common sense, you put it near the top. Now, you could, and then of course all the guys shooting would be in the middle, and the scores on the bottom. And so he would sit there and he'd draw all these characters, and they all have all the artists have a style, and Parker's style can be almost picked out by the faces of the girls. That seems to be the one thing that everybody would pick on. They look at these girls' faces and they say, Roy Parker drew that. I didn't dimension the playboard in any way. I would just put it here. As an example, I had in my bench a series of washers, different sized washers, and I wanted holes up the board. I would lay a washer here and a washer here, and I'd stand back and I'd look at it, and I'd set the flippers down here, and I'd look at it, and I'd say, well, now let me see, I can hit that pretty good, and there's no hole in the board. It's all in the head. You're playing the head. In your head. And now these along here, I put the pop-uppers in here, and where would you put these targets? Would you move them over here? It'd be too far away. There would be no action there. Pull them in a little bit. Pull them in a little bit. So I pull them in a little bit, and that's the way it went. But I start out with a blank board, nothing. It's just blank, and I'd lay out. I lay the arch sticks on it and the card holder and the arch up here, and then I'd take my flippers and lay them here, and I want holes up the board because I know I'm going to knock down these hats eventually. I will do something, and these hats are in the board, and those are glued in from the top on nowadays. But it used to be these hats had ears, and they were tacked in from the bottom, so they were shoved in the bottom, and little tacks were put in, just hammered them in place, and that held them in place, because in those days the plastics had a tendency to shrink, more so than today. You can see these are shrunk a little bit. Yeah, the hats, because they were left over from the old days when they were actually hats. So I'd lay out the board and start right here, and probably, I don't remember, of course, how I designed this game, but I would say I started with 2 flippers and 2 holes, because I liked out holes up the board. But in this game, I set them here, And then the problem comes to get these 5 and 5, and I had targets that I would lay here that would stand up. I had a little form I made up behind the targets, and I had a box full of this. I had a whole box full of parts and junk, you know. I go fishing around and pick out something, and I'd stand these targets along here. They'd stand up, you know, and they'd stand up over there, and then I could get over here and I could look at it and see what the angle is. But then I had to put the pop bumpers in. Now you're limited to how much you can use on a game, how many bumpers you can use, how many targets you can use, how much anything. Well, this game is pretty well loaded with all these drop targets here, 10 of them. That's a bank in itself, as we saw into the playboard, and that's expensive. So you're only limited to so much money. So I had to cut down probably from 3 pop bumpers down to 3 pop bumpers, and maybe I wanted to do 4. If I pull these to the edge and pull them up, I'd have to do something to fill up the space, and I'd have to add more material. So this pulling them in, it you know, it looks kind of vacant up in here, but it I don't know. You look at it after now when it's finished, and I look at it and say, yeah, I could have done something different, but I didn't, and that's the way it came out. And sometimes you do things because you have to do it, and price was always in upper mind, my upper mind, and everybody else's in the company. I would go ahead and once I laid it out, I would then mark around it. I might mark around a bumper with a pencil and mark a hole about where it's going to be, the bumper, or the target, just a little line. And then I would do it more precisely. With my T-square, I could square it off and make this bumper here, this target here, the same area over on this side by putting my T-square on here and drawing a line across, come up with a mark on the other side. And that's the way I'd mark the board. Then I'd drill the board out, add the hats to it, sand it down good. And then I order my parts. I draw my circuit. Once I had the board laid out, I draw the circuit, order my parts, such as the banks, relay banks. I have to order that from, and if any parts I needed, like these troughs, had to be special troughs. I have to make a sketch of the trough, take it to the tool room and tell them, make me one of these. And they had guys that just whipped that stuff out like popcorn. And then I take my step switches and whatever and take it to the relay department. They'd make relays and step switches. And then I would start wiring. I'd put it all together and I'd wire it up and plug it together and play the game. And, I always challenge myself to be able to make a game, design it, lay it out, order the parts, wire it up, put it all together, put a coin in the coin chute, and play the game. Have it work the way I wanted it to. In all the years I've designed games, 150 games or thereabouts, only once did I ever actually make a game without an error in it. There always was a circuit error or an error in wiring or some kind of an error, and I'd have to go back and fix it, find out what it was, and take care of it. But then I get through with the game, I started playing it. And I'd play maybe 15, 20, 30 games myself. And I was a good average player. And I thought, and it ended up that way too, that what I did was pretty average player. And so I kept time how I played, how long, how many games it took to play, 10 games and so on. And I was about average, and if it ran too long, I'd have to do something to speed up the play. Maybe pull the flippers in a little bit, or do something, you know, to change the play. So maybe take hats like this and move them closer to the hole, or pull them back a little bit. Just little tweaks, and then I get through. If I was happy with it, I'd shove it aside, and I'd start the next game. And so I would line up in my room maybe 4, 5, 6, 7, 8 games ahead of production. I would knock them out like crazy.
If a game didn't play really very well, then would you have to start over with the whiteboard?
No, I'd change it. I would change it. say this didn't work right.
But if you had holes in place, what would you do if you
Plug them. I could plug them.
Oh,
say I want to move these 3 pop bumpers. Want to make 4 as an example. I just take them out, plug the holes, drill new holes, and set the pop bumpers back in again.
So you'd kind of glue in a plug?
Yeah, put in a plug. And you know, it's just it didn't have to be a finished product. It's a sample. It's an idea. And then these games I have them lined up in the room, and then now they want to pick a new game. And Dave Gottlieb and the rest of the top echelon would come in, and they'd pick a game, and I'd have the newest game here on this side, and the other game at the far side over here. That's my oldest game. Well, they always wanted to take the newest game because they always thought that was better. And I'd always insisted you got to take the first game because there was a certain progression from one to the other, and so I always insisted on taking that. And usually we could reach a decision.
With those games lined up now, they pretty much did not have official names or any real artwork.
Just the names I put on and the drawings I made. I made drawings on vellum and pasted it and stapled it on the back. And that'd be my drawing and my whatever.
And would David and other people play those games in your workroom?
Yeah, they come in. In fact, during the daytime, Dave would come in, Nate and Elvin, and you know, they come in and they'd play all the games and turn around and walk out, and they knew what was coming up. And so finally, when a day comes and they had to make a decision, then sometimes it got a little heated because they wanted one game and I didn't want that. I wanted the other one, you know, and so we'd get into a little argument occasionally on things like that. But I usually won out. I could out talk them, and we would and take the oldest game. So that's the way it went. And I always had 4 or 5 games. And that picture of me sitting at my drawing table, I think you've seen that picture, and you've seen all the games behind me. I don't know whether you've ever seen that picture or not. If you hadn't, I'll show it to you. It's got a series of games, and the one game over there is the palm tree where the monkeys climb up the palm tree.
It's Tropic Isle.
Tropic Isle. There you go. I had something else on it, but it ended up as Tropic.
I think you called it Monkey Shine.
There you go. It was Monkey Shine. And, you know, the monkey climb up. That was a lousy drawing. But we gave it to Parker, and he picked it up from there and did a nice drawing on it. So, and I could make a game in a hurry. So when I get through the game, I'd have time, and I wouldn't have nothing to do. I could do crazy things, you know. So I thought one day I'm going to make me a race game. And so I started on it. And I took a board, about the size of a playboard. And I decided I'm going to make a racetrack out of it. I think I made a board, I think it was a little bigger than this board. But anyway, I was going to make a racetrack and have a ball running around and have obstacles, of course, but there was a track and have the ball caught over and about here, and then it was a start and a finish. So the ball was in between the start and finish, and when you put your coin in, the gate would go up, and now you tilt the ball. You had 2 levers here. You tilt it like this, you know, the playboard would go this way, all directions. And the object was to get that ball to go around this track, all the way around, come past the starting gate 3 times around, and all this time the clock was ticking. And in the light box was a clock. It wasn't a real clock, of course, but it was numbers that were clicking over. And, you know, if you could get around in 15 seconds, well, that was wonderful. But sometimes it took 30 seconds to get around. But the object was to get around as fast as possible. So anyway, I had the blank board, and Dave and all the guys came in and looked at it, and they just laughed. You're cracking up, Neyens, you know. I said, well, this is good. It'd be fun to play. I enjoy playing it. So Dave said, well, we're not going to spend any money on that. You know, no money on that one. I said, well, I tell you what, if you get me a cabinet, if you paint a cabinet up, I'll make the playboard. And I drew that playboard, I painted every brick, like, you know, the brickyard at Indianapolis. It's all, that racetrack was all brick at one time. I don't know whether it still is or not. But I painted bricks all over this whole area. It must have taken me a week just to paint those things. But it was looking pretty good. Anyway, I got the game finished, and I was happy with it. Nobody else was. Everybody laughed at it. So, well, we'll put it out on location and see what it does. So we put it out. I gave it to a distributor, and they put it out up someplace far north in Illinois, someplace. Had a back glass, but no glass. It was vellum that I painted, you know, with it was homemade.
So you drew out all the artwork?
The whole stick.
No Roy Parker?
No, nothing. A few weeks went by, and we got a report from the guy that didn't make any money. No money, didn't make anything. So I can't believe that. So one Saturday, I don't know, maybe Patty went with me, I don't know. I went up there to see it. Why is this, you know? And it was in a ski resort. Skiers would come in this place and warm up, and we're better than to throw your coats and on top of that game. That game was piled so high with coats, you couldn't see the game. No wonder they never played it, you know. And so I complained to the operator to take those coats off and put a sign, no coats allowed or something to keep the game free. But no, I never got any report back from the guy, and I just forgot about it. I don't know whatever happened to that game. It's out there someplace in space. Somebody's got it someplace in some basement. Well, I made a lot of games like that. I made a 6-player. They called it High Boy, and it had a picture of a man on stilts. And of course, the Lightbox is about that high. And six players, you can't believe it. Anyway, we made one, completely screened and everything, and shipped it out. Never heard from it again. I don't know whatever happened to it. Every game wasn't a winner, you know. We threw out games.
Would you make the decision on your own, or would somebody else want to come in and say it just wasn't?
If I made the decision, it had to be pretty bad. If I decided to throw it out, it was bad. But otherwise, we would argue. We would argue a lot over games. And there's so much fixed cost in every game that what you got to work with is so little. That you know, take a game like this. Every game has a card holder and an arch and a cabinet and coin chutes and shooters and glass, you know, and transformers. They're all fixed costs. The motor fixed. So what do you got? You know, the fuses. All that stuff is a fixed cost. And the poor designer, poor me, had to work with a little bit, just a little bit. I always wanted more, you know, more material, more features. All right, well, let's see what we have here today. We have a score motor made by Gottlieb, and it looks awful. It looks awful, but you know, this thing grew up from Topsy. It just kind of grew up, and first one we only had maybe 2 or 3 switches on. And then we added a switch, and it just grew. The important thing to know about motors like this, they're really not as complicated as they look. If you understand which position is which, and on every circuit there's a little picture of the motor, and it points out the areas. Now, if you look at the back of the motor where the coil is, that was we call the back of the motor. Well, diagonally opposite it, over on this side, we don't call that 1. So that was point 1, and going up from the bottom is A, B, and C, and D. A be in the bottom, B would be in the middle, C would be here, and D is on the top. So when you see a switch in the drawing that says motor 1C, you know exactly where to go. You don't have to look anyplace else or worry about anything else. That's the only position you go to, 1C. Get the position you want and go to that and stay there until you find the problem. But so then you go from 1C to 2, 2A, 2B, 2C, 2D, and so on around the motor, and 4C over on this side. And if you look at it in that light, it's very simple. It looks complicated and it's hard to get at. Now, some games, the motor is fastened to the bottom panel and you can't get it up. And in the later games, they're held down by a member, and you could just have to take a hairpin out and the motor will tip up in this fashion. And then you can work on switches from this angle, which is a big help. Particularly, the motors is loaded more in the one position than any other position. So it's very important to see that area, and that's why we made the motor so it would tilt up in this direction. If your motor ever overrides, in other words, it makes it cycle, a third revolution, 1/3 revolution, and continues on without stopping, the chances are this brake switch is not working, or it is broken off. So it's a good thing to know that that switch is under there. It's not a switch, there's no electrical circuit to it. As you see, there's no wires connected to it. It's just a switch to stop the motor from overriding. And because some of them will do that, if not enough pressure on the cams, why it could ride over, and then you get an extra pulse or extra 5 pulses, and that's not good. This would be where the wires come in, and diagonally opposite is 1. And then going around the motor clockwise is 1, here, 2, 3, and 4. And then you're back to 1. Now that stop, that 3.5 stop, always look at that if you have motor trouble. Only if you want a count of 5, then your relay pulls in, a 5-point relay would pull in, and that would make the circuit to the motor, turn the motor on, and the motor would start out. And also that same relay then would put a current to the 1A switch, in position 1A, and it would score 5 times. Now, if it don't score 5 times, you know right where it's at. It's right on that 1A switch, or on the relay, one or the other. If the relay switch feeding the motor is not working, well, then you wouldn't get any count. Now, the motors we bought, these are purchased outside the plant. The frame we made, and the switches we made, we stamped them out. The spacers we stamped out and assembled them all. And now the spacers, of course, are bakelite or fiber of some kind, and they would tend to take on water and swell. And now you wouldn't think that'd be much of a problem, but they don't swell much, but they swell it just a tiny bit. And you have a big stack like this with 4 switches, and sometimes more, and you put it on the motor, and the motor runs for, the game plays for a few days, a week, a couple of months, and that bakelite that begins to dry out, and the switches become loose, and they lose their adjustment, and we have trouble. So what we did was we stamp out the spacers and put them in a big barrel. Spacers were under heat light at all times, day and night, 24 hours a day, 365 days a year. And when we needed some, the department head would go over and take a shovel or a little hand shovel and dig out a couple 100,000 maybe, and put them on a tray and hand them out to somebody to use. But they're always in that barrel, and that's a large barrel. It's probably 3 feet, 2.5 feet in diameter and 3 feet high. And so you'd have jillions of them in that barrel, and always under a light treatment. Dry them all out, keep them dry, and then they'd use them right away and screw them on the machines. And of course, then they stayed tight. Now, a lot of companies didn't do things like that, but that's one of the things that Gottlieb did that helped make the game stay working and kept our switches in adjustment. This is a decagon unit, one of our scoring units. It probably looks a little different to you when it's outside of the machine like this, but this is the way we worked on them, and You can see it's called a decagon unit because there's 10 sides. See the flat side is 0? And it made it difficult to screen, as you can imagine. We had, these were molded, the discs were molded, and with a flat side, but then we had to go ahead and screen the numbers on, and that was a process it took a lot of thinking how to do that, and we finally got it down pat, and they were able to screen those numbers on there like that. So that was really a big improvement. So the number looked flat against the window of the glass, not round like most score units that you're familiar with. Now they all have a slide, and they operate. You can operate them with your finger. Grab a hold of the plunger and pull them and watch them. And we have this switch here now. That's a switch, end to stroke switch, that when the relay pulls in, a relay that's going to operate this unit, it pulls in, makes a circuit, makes a contact, pulls this coil in. So the coil pulls in like this, coil pulled in. Now it's got to drop the relay out. Well, that's what this switch right here does. It drops the relay out, and the relay going out, the switch opens up, and that drops out, and the score is, its immediate cycle is ended. That's the 9th step switch. If your game, if the first digit don't make the second digit move, the chances are it's right on one of these switches right here. This little fellow is called a 0 to 9 unit, and you've seen that, and we talked about that when we were looking at the game. It's a unit that determines what the match number is going to be. And we call it the 0 to 9 unit, and that runs a series of lights from 0 to 9. And when the game is over, the game over relay will feed a circuit that will turn on the light that this unit is stopped on. Now it could be anywhere from 1 to 10, and it's got a little bell on the bottom, and it's like a score unit, and like this, all these numbers on here, it probably is feeding lights too, but it's got the bell on the bottom. Just if I can get my hand out of the way under here and make it. Here we have a relay bank. We can make it in any length. We can make it 10 or 12, I guess, but mainly 5, 6, sometimes 4, 3. You hit a bumper or go over a rollover, and I'll spool them all up here first. Now you see that one tripped off, and this one would trip off, and then you hold in that position. So if you went over a rollover switch or a rollover button or something, and you impulse that relay, that wire, this relay would drop. And now if you dropped all 5 of them, or 4 or 5, whatever it was, why you would complete a circuit and then accomplish a feat. You might run the motor at that time, and the motor would run around and score or whatever, and then it would impulse the solenoid and set them all back up again, and then you're ready to knock them down again. And you go along and hit the switches on the playboard at various places, knock them down. They're all down. Now a relay would pull in, pull up, and reset them. And this bank is made that if you have to work on it, if you want to see the switches, you know, it's almost impossible to look under those switches. So there's 2 wing nuts on this bank, and on every bank, so that you can open it up, just unscrew them like that, open them up, and then you can raise them up. When it's screwed down to the board, you can do it more easy. This is kind of difficult trying to hold it in one hand and do it. But then you do this with it, and you can set it over like this. And now, of course, this is held down on the board, these brackets, and you can work on these switches up here, and you can see what they're doing. You can look at them, do this with your finger, push the latch, the armature down, and the latch falls, and you can check your switches, and if necessary, clean them. Use a little burnishing tool to clean those contacts with. If you have to use a file, very gently. You don't want to take any silver off of those switches, off those points if you can help it. A burnishing tool is the best thing you can use on cleaning contacts. All right, now this is called a berry target. This is designed by Ed Krinsky, by the way. And it mounts on the, underneath the playboard, goes up, and this target protrudes above the playboard. And depending on how hard you hit it, how accurately you hit it, it goes up and stays there and scores. And when it gets through scoring, it releases and gets back to zero, back to its normal position again. But if you hit it square on, you drive it way up here, and of course that gives you the highest score. And when it gets through scoring, that relay pulls in and drops back to zero, and back to its normal position. When the ball hits the target, it goes up, and the higher you go, the higher the score is going to be. Now, when it gets through scoring, this magnet pulls in and releases it, and it goes back to its normal position. And now, what happens when you pull it up, you see these rivets back here, there's a disc back here, and when you pull up like this, you make contact with a rivet back there. This is made so a relay pulls in, scores, whatever this indicates, whatever these two contacts indicate back here, will score the amount of points that you needed, and then when it gets through, it'll kick this in, kick this relay in, and resets to zero and ready to be hit again. This little gadget here is a replay unit, and you know, most everybody knows what a replay unit is, and this one has got 26 steps on it. And every time you win a free play, it goes up one. Now I'm gonna lay it like it's in the Lightbox, and it's. Let's see what we got here. We're on 4. All right, we're going to go down to 0. All right, over 0. Now we're in the Lightbox, and you can see the 0. Now the glass is in front of it here, and it's got that little opening about an inch square, so, and it shows that 0. Now when you win a free play, the solenoid pulls in, steps up 1. As soon as it steps up 1, these switches on the back are activated. And they then close the circuit to the free play button on the front door, so that you can now play it for free. It's just all you have to do is push the button and you can play a game. And so on it goes. And when you play a game off the free play unit, you impulse it once and it goes back to 0. Now if you win more than one game, you 1, 2, 3, 4. As an example, you won 4 games. And now you play off 1, goes back to 3. And then after you finish that game, it goes up back to 2. Now if you happen to win another one, it would step up to here. This is only, it's a drop target, and there's only 4 of them on here. Now this drop target bank can be made in any number. According to our dies, we'll chop this out in any number that we want. We want 4, 3, 2, 10, 12. We could cut it off at any time. So this could be anything. Be on the right-hand side of the Spirit of 76. See, on the left-hand side would be 1776, and on the right-hand side, 1976. And that would be another unit identical to this on the other side, and the switches on the back show that it's down. Now I'll pull the switch up, pull the target up, and you see that switch there open up. Now when it goes down, makes contact, and that scores. That'll score whatever you want, whatever you set it at, whatever we wire into the game. So drop, it scores, and so on down the line. Each one would score, and then and when you want to reset it, when they're all down, and for some reason the game is over, you want to reset it. These switches are closed. This solenoid then pulls in and sets all the numbers up. There they go. Now they're all back up. The playboard sits here, about my hand. My hand would be the playboard, and those numbers that stick above the playboard. The ball comes along, hits it, and you can see it disappeared. It's down below my hand now. And that's the way the drop target works. All right, now here we have the very famous pop bumper. Everybody knows what a pop bumper is, I think, and it's a wonderful invention, and that was Charlie Castaker. American Molded Products came up with this little gadget, and we every company used it, and it works so that you the switch that goes with it. This is the switch that I designed. I might as well get a plug in here. Without that switch, this unit would never have worked. But this switch mounts up underneath it. I'll try to hold it around here. See where that plastic stem from the skirt of the bumper fits into that little indentation there, and when the bumper moves, wait, I don't like it. Perhaps you can see that. You see it rises up against the bumper, and as the solenoid pulls down, it pulls down and propels the ball outward, and it'll stay down until the plunger gets to the bottom and open up the switch that is on the bottom of it, so that it drops out, and then it goes back to position and ready to go over again. That's why pop bumper pop back and forth quickly. And this is a balls played unit, and this counts the number of balls played, and that some games are 3 balls, sometimes it's 5 balls, and this would determine which one you're going to do. Let's see, if we go. Yeah, now this goes up beyond 5. So, you know, an add-a-ball game, it goes up to 5 stops, and you play, and then if you win a ball on the first ball, it would go up to 6, or it would go up to 7, up to 8, and then you lose, it would go down 1. And when you get back to 0, then the game is over. You want to keep them wanting.
Yeah, but you want them to buy what you got, not wait for the next one.
What difference? You know?
I guess.
What difference? See, Gottlieb didn't care
Sales.
what they bought.
Total sales. That's all.
Total sales. At the end of the year, what was the? How much money did we make?